Okay guys, in this video I want to look at some theorems that basically say if we have these conditions, then we know we have a parallelogram. So in the previous videos we've been talking about, okay, here's a parallelogram, here's some properties of parallelograms. Now we're going to say, okay, if this quadrilateral has these characteristics, then we know it must be a parallelogram. So there's kind of four theorems here, and then we're going to do some problems over there, but there's four theorems here, and basically I want to show that each one of these cases yields a parallelogram. So that's going to be our goal here. So if this situation happens, if this given happens, then the quadrilateral must be a parallelogram. So let's get started. Okay, I'm going to draw a line. So the first situation is if opposite sides of a quadrilateral are congruent. So if opposite sides of a quadrilateral are congruent, then the theorem says we have a parallelogram. So why is that true? Well, if we draw a line from here to here, okay, then we know by SSS, okay, SSS, that these are congruent, okay, that these are congruent. The two triangles, I should say, are congruent. So if the two triangles are congruent, then we know that this must be x and x. We know that this must be y and y. We know that this must be z and z. Okay, so corresponding angles of congruent triangles are congruent, so this situation would be true. Therefore, by the alternate interior angle theorem, if you have alternate interior angles that are congruent, you have two lines and one line intersects them, and their alternate interior angles are congruent, then that shows that these lines must be parallel. Okay. By the same logic, you know, if you draw another line and do the same thing, then you could show also that these lines are parallel. Okay, so by that logic, that's how we're going to do that. Moving on to our next picture. What this says is if there are opposite angles in a quadrilateral that are congruent, so two opposite angles are congruent, then we have a parallelogram. Now, why is that true? Well, again, we have two lines, and they're cut by another line. Okay, so we have two lines cut by another line, and we know that all of these angles, all four of these angles, must add up to 360. Okay, so these four angles, let's see here, we'll call this 1, 2, 3, and 4. So angle 1 plus 2 plus 3 plus 4 must be 360 because this is a quadrilateral. Okay, so if that's true, and these are congruent and these are congruent, okay, then we could imagine this is, for example, let's say this is x degrees. So let's say this is x, x and x, y and y. Okay, so x plus y plus x plus y must equal, let me write this down, x plus y plus x plus y, so 2x plus 2y equals 360. So x plus y must equal 180. Okay, so if x plus y equals 180, then we know that these two angles equal 180. And when you have two lines that are cut by another line, and these, let's see here, these two angles are going to be, if they're supplementary, okay, so if these two angles are supplementary, these are consecutive interior angles, then we know that these lines must be parallel. Okay, by the same logic, we know that x plus y here, if those add up to 180, so we have two lines cut by another line. If these are 180, then we know that these must also be parallel. Okay, so moving on to here, let's see here. We know that, all right, so we're given that we have this situation where the diagonals bisect each other. So the diagonals here bisect each other, and we're trying to show that the lines are parallel. Okay, so how do we do that? Then we know that these two angles are congruent, right? So we know that this angle and this angle are congruent. Sorry, we know that these two angles are congruent, so I skipped a step. These two angles are congruent, so by SAS, then these two triangles are congruent. So if the triangles are congruent, corresponding parts of congruent triangles are congruent. So circle is congruent to circle. Triangle is congruent to triangle. Okay? So if that's true, here we have two lines cut by another line. Okay, two lines cut by another line. And we see that the alternate interior angles are congruent. So if the alternate interior angles are congruent, then these must be parallel. Okay? By the same logic, these two vertical angles are congruent. If these two vertical angles are congruent, we know that this is x, and this is x, this is box, and this is box. And so by the same alternate interior angle logic, we know this must be true as well. Okay? Finally, going down here, we know that we have this situation. So in other words, we have two parallel lines that are congruent. Two parallel lines are congruent. Okay? What I want to do is I want to draw a line here. Okay? And I want to draw a line here. So we've drawn these two lines here. Now, we know that these are parallel. And so that's going to be really critical here, because then we know that these alternate interior angles are congruent. So here is congruent to here. And here is congruent to here. Okay? So by ASA, so triangle, side, circle, by those angles, ASA, these triangles are congruent. In other words, this and this are the same, these and these are the same, and then we're right back up here. So if we apply this theorem that we just proved, then if you have this situation where the diagonals of a quadrilateral bisect each other, then it's going to be a parallelogram. So if any of these four cases exist in a parallelogram, or sorry, in a quadrilateral, then the quadrilateral must be a parallelogram. Let's look at some examples. Okay, so does this apply, or does this have any of the theorems that we just proved? Well, this looks like this first one. Okay, we're given that opposite sides of a quadrilateral are congruent, so we know this must be a parallelogram. Okay, so because of the opposite sides are congruent, we know this must be a parallelogram. Okay, so in a parallelogram, we know that these two angles are supplementary, so x is going to equal, it looks like 130 degrees, and y is going to equal, again, these are going to be supplementary, so y is going to equal 50 degrees. Okay. Here, we see that we have a quadrilateral. Don't know if it's a parallelogram yet, but it looks like opposite. These are 110. This is 70, and if you add these up, that's going to be 220 plus 70 is 290. So there's 360 total. So this must also be 70. So because of that, then we can apply this theorem. Okay. In other words, these are going to be parallel. Okay. So what do we know then? Well, we know that parallelograms have congruent sides. So we know that congruent opposite sides, I should say. So 4x minus 3 equals 9. So 4x equals 12. X equals 3. Okay. Similarly, we know that these two opposite sides should be congruent. So it looks like we have 2x plus 7 equals 3x minus 5. But we've already used x, so these should actually, we're going to change these into y's. Okay, so those are going to be y's. So we have 2y plus 7 equals 3y minus 5. Okay, so y equals 12. So I move the 2y, the 5, y equals 12. Okay, now again, in this case, We don't know if it's a parallelogram, but it looks like this is going to be the same as this. Okay, so the diagonals of a quadrilateral bisect each other. So if that's true, we know that this must be a parallelogram. Okay, parallelograms, we know that these two angles, so two parallel lines cut by a transversal, the alternate interior angles, x is going to equal 30 degrees. And again, looks like we have an x here. We're just going to change that to y. Okay, we know that these two sides must be congruent, so 3y equals 7y minus 8. So 4y equals 8, y equals 2. Okay. And finally, down here, we see that we have this situation. So we have parallel lines that are congruent in a quadrilateral. So what that means is that x, okay, that means, again, if we have this situation, then we know that in a parallelogram, diagonals bisect each other. So if this is 3, we know that x must be 3. And if this is 4, we know that y must also be 4. Okay, finally, we know that if ABC, angle ABC is 60 degrees, so this is 60, okay, then we want to find angle DAB. Okay, so notice that these two angles are going to be supplementary. Why are they supplementary? Because we know that this is a parallelogram. Okay, in parallelogram, two consecutive angles are going to be supplementary. So the measure of angle DAB equals 120 degrees. All right, hopefully this video gave you a decent idea of what we sort of need in order for a quadrilateral to be a parallelogram. You could see how we applied that, and hopefully that helped you get the concept a little bit better. Thanks for watching.